morning. My name is Bahadhur Pandey, Assistant Professor of CMR Engineering College, Hyderabad, branch of CSE AI&ML. I am going to explain here bottom-up parsing and shift-reduce parsing. So basically, this bottom-up parsing constructs the parse tree starting from the leaves and then working up towards the root. Here we perform the rightmost derivation in reverse order. For example, the rightmost derivation of string A, B, B, C, D, E using this grammar is derived A, A, B, E and A derive A, B, C oblique B and B derive B. First of all, I will explain to you what is this rightmost derivation. Rightmost derivation is that here we are going to derive from rightmost non-terminal first. So S derive rightmost derivation, that is S derive first production, that is A, A, B, E. So S derive A, A, B, E. Now here rightmost non-terminal is B. So next time we are going to use this handle B and this P derive B. So here rightmost derivation towards left side. Next, the next non-terminal is A. So here A derive A, B, C. This production is given here A derive A, B, C. And then rightmost derivation again. So we are going to perform the next rightmost non-terminal. This is A. So this A derive B. Finally, we got this A, B, B, C, D, E. So this is called rightmost derivation for any string using this production or grammar. Now come to the bottom-up parsing. See, in bottom-up parsing, we are going to perform the rightmost derivation in reverse order. Okay, so we start with the string. First of all, string here I am written here A, B, B, C, D, E. Here we are going to apply these productions in the way where rightmost derivation in reverse order. So first of all, this A derive B. So last production here, that is A derive B. So this is in reverse order we are going to perform. So first step is the last step. So here we perform A derive B. Next step is here we are using this A derive A B C. So this A derive A B C. Again, next step there is a that A B E and this A derive A B C and B derive D. And finally this is derive A B E and this A derive B and this A derive A B C and this B derive D. So this is the rightmost derivation in reverse order. So after that is called bottom-up parsing. In bottom-up parsing, we are going to perform rightmost derivation in reverse order. After that, I am going to explain here the types of bottom-up parsing, that is the shift-reduce parsing. Shift-reduce parsing is types of bottom-up parsing where we are going to perform the shift and reduce operation for given grammar. Okay, so basically this shift, the next input symbol from the right string on top of the stack, that is called shift operation, and then reduce, identify a string on the top of the stack, that is the body of production, and replace the body of the production with the head, that is called reduce operation. So here the initial condition for shift reduce parsing. Shift reduce parsing, first initial condition and final condition. Initial condition, there are two things. One is a stack and there is a input. So what is the initial condition of the stack? That is the initial condition is dollar. Here only dollar input is there, and input there is a W dollar, where W is the string given in your props. Now what is the final condition? This is the initial condition of shift reduce parsing. Now here we are going to perform some shift and reduce operation, and finally we reach to the final condition. In final condition, there is a start state, dollar with start state, and here empty, means that is dollar. So that is the final condition for the shift reduce parsing. So finally there is a $S and there is a dollar. Okay, then we announce that the parsing is successful, happen, and it will accept. So here I will take one example. Suppose there is a grammar E derive E plus T oblique T derive T into F oblique F, this F derive in bracket E oblique I. Okay, now here we are going to apply this production with the string, that is one string is there, that is w equal to id1 plus id2. Here w is equal to id1 plus id2 into, this is the string. Now we are going to pass this string using this grammar for shift reduce parsing. So first of all, here we are going to use stack, then input, and then action. So first of all, we are going to start with the initial condition. So we know that initially stack is empty. Here only dollar input is there, and then input is w dollar. W means string, that is id1 plus id2 dollar. Here this is id2. Okay, and action. What action we are going to start? So first we are going to perform shift operation. So shift means we are going to shift this input to the stack, top of the stack. Initially stack is empty, so here we can perform shift operation. Shift. Now this id1 is shifted here, so dollar id1. Okay. Now here plus id2 dollar. Sorry, this is not plus, this is multiplication asterisk. So this is asterisk id2 dollar. Now here we are going to perform this f derived id. So this f derived id, where is, this is the production f derived id. So here we are going to reduce f derived id. Then here we write dollar f. Here asterisk id2 and dollar. Now again here we are going to perform this reduce f. So this t derived f. So here we can write reduce, again reduce t derived f. So this f get reduced here with t, and here dollar multiplication id2 and dollar. Okay. Now again we are going to perform shift operation. So here we write shift. Now shift this asterisk here. So dollar t asterisk. Now here id2 and dollar. Again we perform here shift. So that is id2 is shifted here. So dollar t asterisk id2. Again we perform reduce operation. So reduce f derived id. So this id get reduced here. So dollar t into f, and here dollar, and here this t into f. So this t derived t into f. Again we reduce t derived t into f. Reduce t derived t into f. Okay. So here we can write dollar t, and here we can write dollar. Next, again this t, this e derived t. So again we reduce e derived t. Reduce e derived t. So here the dollar e, and here empty, and this is accepted. So this is the final condition, dollar start state and dollar. So that is the accepting condition. So here we can write accept. Okay. So this is the method of shift reduce parsing, where we are going to perform shift, reduce and accept. Okay. If it is not accepted, if final condition is not like that, start state and empty, then that is error. So basically there are four operations that we are going to perform here: action, that is shift, reduce, accept or error. If it is not like that, dollar start state and dollar, so that is error. If it is like that, so it is accepted. So there are four kind of action, and here we are going to use one stack and one input. Okay. Thank you.